So I don't know.
Call it type, so instead of integers, you want an array.
So that's
You call it an array with brackets. I think that's what we're talking about.
So that's what static.
Yeah. Because an array can be anything. You just have to put those brackets to call it. Yep.
All right, everybody, let's get started. So today we are making our transition into the second half of the class, which I think is really exciting, where we will be focusing on data structures and algorithms. We will be using Java, and we'll continue using all of the nice things about Java that we've learned about classes. We'll continue using generics, etc. But we are going to start thinking about data structures and algorithms as our main focus. But I've been hearing some talk about the lab, and I want to remind you, so I'm going to click into the lab. What I want you to remind you about is that this is mostly or partly about generics. And so if that doesn't really mean anything to you, if like these angle brackets and type parameters sounds unfamiliar, then go back. Don't try to do the lab yet. Go watch this lecture. Hopefully there is a lecture video here. Looks like there is one. Go watch that lecture. And in the lab description, look at this example of making a generic method. Because you really should be making like so few changes to the integer swapper, like probably replacing like max 20 characters. So if you are writing more code in the actual integer swapper than like 20 characters, then that probably means you're doing something that's harder than you need to be doing, and you should really look at the stuff about generics. Yeah.
I was kind of curious with generics. Is there like standard letters you want to default to, or?
I don't. Well, so yes, T for type I think is a pretty standard one, and then we've also seen that when we had two type parameters, we used A and B. But other than that, I am not aware of any other standards. But maybe we'll come across some in the rest of the class. Definitely, like, feel free to Google it. Let me know if you find anything. But that's as much as I know. Cool. So, all right. So, yeah, and generics are gonna like keep coming up for us too. So, it's good to get some practice. All right. Okay. So. Today, we are going to start thinking about arrays as data structures. And so I actually wanted to start off, you can see my lecture page here isn't actually complete because I wanted us to just think about this together. And so I'm just going to edit this. It won't be there immediately, but I didn't want to kind of give it away. I wanted to let us have this conversation together, and I bet this needs to be very large because that screen is just so much smaller than it needs to be in this big room, but that's fine. Okay, so can anybody tell me like what comes to your head when you think of data structures, or if you've learned about them before, like what is a data structure? I see a hand from Forrest, yes.
A format that we use to store memory.
Yeah, well, do you want to elaborate on that?
Yeah, so, memory is just going to be differences in ones and zeros at the base layer. I guess what I'm trying to say is that a data structure is a way of storing information in a cohesive and manipulative way.
Yeah, so a way to store information that's a higher level of abstraction of abstraction than ones and zeros. Like, yeah, I think that's true. Any other thoughts? Like, these are just ideas. Yeah.
A lot of times it's used for organization. For instance, like a linked list would have like a head and tail and have like a sequence of going through the objects in order and replacing them in such a way that they can someone can make the use of it.
Yeah, it kind of it maybe has, I think you had kind of two ideas there. It has defined, we have defined operations that, like, as a user, we want to be able to do these things, like get the head of the linked list, the first object. So has defined ways that we interact with it. But then it also has an implementation. A linked list is a way to implement something that we can do we can get the first element and we can put something new in it, etc. Any other thoughts? Okay, so yeah, and I think we will continue kind of formulating this together in the next couple weeks. But really, I kind of think that this implementation is what we're really going to be focusing on. So we can do certain things, but how do we guarantee that we do those things? And we'll see that specifically with arrays. So now let's think about, today we're going to start working with arrays as data structures. Can you think of any potential benefits that arrays have? Like, what can we do with arrays? Yeah, so we can hold multiple, we can call it pieces of information. And what else? Yeah. Yeah, because of the above, we can have algorithms that deal with multiple pieces of information instead of just one. Let's see. Any other thoughts? Yeah. Yeah, and I guess in Java, we already have array objects with predefined methods. So yeah, that is definitely true. What about, so we haven't been working with sets in this class, but if you think about a set, maybe not like in math or something like that, well, one thing, so I guess, what about the fact that arrays are ordered? Does that, so far everything I've written down is just, we can use we can like store multiple pieces of information, but arrays also have this property that I don't just know that I have a 5. Like I put my 5 in the first slot, or I put my 5 in the last slot, right? So the information is ordered. Let's see. Can we change arrays? So actually, we can actually change arrays. Like, I can, if I had I don't know. We can double check, but.
Create a new array.
So.
If we add something to it.
No, I think we, oops, this isn't this is that. I think actually we create the array, we say how many elements it has, and then, I can put, let's say I create an integer array, right? Array of ints. Say I say array of 10 ints, and then I put the number 10 in like index 0. I can then say, no, index 0 is 5. So I can change the elements. Yeah. But yeah, I mean, it's a good thing to think about. Yeah.
Can you change the array line?
Yeah, so that's a really good. Okay, so the information is ordered. I'm going to say we can change what is stored in each slot, because yeah, like immutability can be a benefit maybe for other things, but also maybe it's not a benefit. But for us, we can change it. But so a drawback, I would say, is we can't change the length, right? Yeah. Yeah. Another drawback. We can only store one data type. Yeah.
If we need a class with like multiple different data types and then created an array of that class, then using that class, would we be able to store multiple data types in one array?
A class of multiple different data types. Are you thinking, well, so I have my, okay, I guess, are you thinking that, like, just as an example, are you thinking, I have my public class, example class, and are you thinking that it has a field like string field 1, and then I also have an int field 2, and these are like attributes of the class, and then somehow I'm storing an array of example class?
Yeah, so I guess maybe if you had a constructor with a generic, so
Yeah.
generic constructor, and so you could pass in like variable into the class, and then
Yeah, so I mean So yeah, I'll say that I don't want to say like definitely no, because I would probably be wrong. But in general, in Java, I would say that we do think of arrays as only holding one type. So that's pretty much going to be a fixed thing for us. Yeah, I think I'm not seeing a way that we would make the array of actually be able to hold different data types, basically. But again, a lot of times when I make sweeping statements, then they turn out to be wrong. So not going to make too sweeping a statement on this. Okay, any other thoughts on, benefits of arrays, drawbacks of arrays? Yeah.
You can have multiple non-unique elements, or you can have multiple,
You can have duplicates.
Yeah.
Yeah. So yeah, kind of just like, I don't know if it's a drawback or it's just a thing. Maybe it's a benefit, maybe it's a drawback. Can store duplicates. And yeah, I think that's a good point. Okay, so I think we've got a pretty good list here. So let's see an example. And so I'll clean those up a little bit, and then they'll be here eventually. So let's suppose that I want to be able to hold n high scores, so some number of high scores. I want to rank them, and I guess I said in an array, but really we'd have to think to ourselves, well, what's the best tool for this job? And surprise, surprise, an array is a good tool for this job. Because we had to specify n, right? So we know that we know how big we can make our array, and we can maintain this scoreboard because we can move. Luckily, arrays are mutable; they can be changed, and so what we're going to do in class today is we're going to implement this scoreboard class, and so we can see here, okay, what am I talking about? Well, we just want to be able to represent something like this. We've got a list of high scores, so we want to be able to represent a name and then the score, and we want these to be ordered. So what are we going to do? Well, the big idea is going to be to write a class scoreboard, and can anyone tell me, okay, just starting to think about it, I've already told you I want an array, but what should that array hold? Does anybody have any ideas? Yeah. Yeah, what was that? A game entry, yes. Perhaps you saw that on the website. But okay, so what is a game entry?
Has a couple people's scores as well as the game's time scores.
Well, okay, just one game entry. How many people's scores should one game entry have? Yeah, one game entry is just going to have a name, like Mike, and it's going to have a score. And so if we have our arrays of type game entry, then we can store these in our array. So, great. Oh yeah, we already had this up. Okay, so this is on the website as well. But here is a really simple implementation of this game entry class. Let's see, it's got everything that kind of makes sense. We've got a name, that's a string. We've got a score, that's an int. We've got a constructor that takes in a name, and it takes in a score, just sets those. And then we've just got some getters and a nice toString method so that if I just say system.out.print, I can print out one of these game entries. Okay, so great. We've defined a game entry. Now, let's also, in the same class, or in the same package, I am also going to make a scoreboard class. All right, so here we are. We're building our scoreboard, and so we can always think to ourselves, we've got fields, we've got constructors, we got methods, and I already told you that I want to be able to add to the scoreboard. Okay, so that's pretty much all we've got, I would say, at this point. Public void add. And let's say that we're going to do that in a bit. So we know that's going to happen, but can anyone, I call this score with an A in it, huh? Let me refactor to score board. Great. Okay. Well, what am I going to have in my scoreboard class for my fields? Any thoughts? What was that? Well, okay. So, all right. So if I had a name in here, like what would the name, so let's come back to our drawing. So this is supposed to represent our scoreboard. Or this is like our scoreboard. It's got, in this case, you know, this could be one state of our scoreboard. It's got 4 entries in it. So if I had a single name in my scoreboard, which, like what? Okay, so we need an array. But what is the type of our array? Yeah, it's a game. And I guess I'll make this nice. So we're gonna have, what is my, oh yeah. And so I have an array of type game entry, and I'm gonna call it board because that makes sense to me. And it makes sense to the books. And that's really what we're going off here. Okay, so great. I'm gonna have this array called board that holds game entries. What else might I need? And maybe we can come back to this, yeah. Well, so I couldn't, if I did something like, so here's where I think sort of the important design choices that we're making. So here we are making an array of these game entry objects. Our other option would have been to make, maybe we could have one array of strings, names, and another array of type int for scores, right? So I'm going to say I'm going to say the cleaner choice, and the sort of, I would say, less object-oriented, possibly harder to maintain choice, would be to have these two separate arrays of names and scores, right? And now I have to move stuff around in both names and scores. But if I don't do this, if I instead just have my array of game entries, then I just have a game, like one game entry holds both a name and a score, right? So let's jump over here and see. Okay, I really cleverly spent some time redrawing a figure from the book. Let's see, no, I can't zoom in on this. But the idea here is that, let's say that this is a scoreboard object, right? So let's say this is an instance of the scoreboard class. So we have an array with 8 slots, right? And that's what this is, like these little holes are supposed to be, is we've got an array with 8 slots, and so it's indexed from 0 to 7, and currently in this example it has 4 things in it, right? And can anyone tell me any guess what my drawings are supposed to be? Like, what are being held in each of those 4 slots? Yeah. So there's supposed to be remote controls, because this is copied from the book. So the book really likes this analogy of objects. Like when I hold on to an object, I've actually just have a pointer to, like this is true. Remember, reference data types, the variable, what's actually stored in the variable is the memory location. So what's stored in the variable is a pointer to the object. And so a lot of times we represent this like, a lot of times we'd say like, we do this like other books. Other books might represent this, again, if I want an array, 0, 1, 2, 3, 5, 6, 7, 1, 2. So a lot of times books will do something like, what is stored in 0? It's a pointer to a game entry. And a game entry, has a mic and 1105. So this is what a lot of books will do. Our book really likes this analogy of remote controls. So these are saying, okay, there's a remote control and it's pointing to the game entry that is Mike and 1105, which you probably can't see because it's too small. But the point here is that in each one of these slots in the game entry board, we hold a game entry object. And a game entry object has both a score and a name. Does that make sense? Cool. So, yeah. All right, so I'm going to delete this. Can anyone think of any other possible fields that we might want? Yeah, so I'll make this private as well. So, and why do we want to keep track of number of entries? Yeah, I kind of need to know, like, where should I add in a new one? Or am I too big? You know, let's say my scoreboard already has 10 entries in it. I should do something differently if it already, or 10, like, let's say I initialize it. Well, I need to know how big to make this board, right? First off. Or no, that's not true. I choose how big to make the board separately. I need to know where my last one is that I'm currently holding. So that's why I'm going to need num entries. Okay, so I think that's good for that. So now let's think about our constructor. Let's make this public. We know it's going to have scoreboard. So let's look back at the description of our scoreboard. I want to be able to hold n high scores. So this is we should be able to specify how big our scoreboard is. So with that in mind, can anyone tell me how I should write this constructor? Is there anything I should take in here? What was that? Yeah, sure. Yeah, I need to take in the size that I want to make my scoreboard. So construct a scoreboard with n slots. So this means it can hold up to n scores. And what should I do in that constructor?
So it seems like we have a middle factor here, which say n is the num entry is assigned n, and they can use num entries.
What was that?
So you're going to take your n value, and you're going to give it to number of entries, and then make your board value assigned to a new game entry array of blank number entries.
So this is a good idea and makes sense that you would, like, as a first thought, and I would probably think this same thing at first, but if we did something like board is new, so we definitely want to actually initialize this board, right? So it's going to be a new array of game entry, and okay, so we want to do this, make board a certain size. But this, I guess, so num entries is actually going to keep track of how many do we currently have. And so we can actually set this to 0 at the start. And so we want to make our board, in fact, n size, right? That's how we make it have n slots. And at this point, I'll say, note that num entries is still 0 because there are no scores, I'll call them game entries, in the board yet. Okay, so we can make one. That's awesome. Now, the hard part, how do we actually add game entries to this thing? Yeah, that is a great point. So definitely want to actually take in a game entry. Let's just call it E for simplicity. And then, so when I'm writing code that's getting a little bit more complicated, I like to start by implementing, even though it's not, in the end, I want add to kind of handle all the cases. Like, what should I do if this score shouldn't even go on the top in my scoreboard? Like, it's just a really bad score, the scoreboard's already full, and it's worse than all the scores in there already. So I want to get there, but I like to start with something really simple. So let's just say we don't care about keeping these in order. We don't care about overfilling our array. Let's just try, what should we do if we wanted to add this game entry at num entries, right? So let's say I just wanted to do something really simple. Yeah, you want to tell me how to do that?
I hope I'm right.
Yeah.
But I think that you would use your current num entries value and then assign it to that index.
Yeah. So if I just wanted to put in this game entry at num entries, I would do something like this. I'm assigning board at num entries to E, and then what else might I want to do? Yeah.
Increment your num entries.
Yeah, exactly. And so if all I wanted for this scoreboard was just I knew that I wasn't going to add more than n, and I didn't care about them being in order, then this add method, I think, would actually work, right? Because num entries is always, before we've added anything, it's 0, so I'm going to put it in the right place. I add one thing, now num entries is 1. I put the next thing in the right place. But we don't just want to do that. We want to be able to maintain our order, and we also don't want to overfill our scoreboard. So what are we going to have to think about to make that happen? So shall we try to look at my nice picture? Yes, let's do it. So again, going back to the picture that your book draws, and these are probably too small. Okay, this is 0. And okay, so let's say that we assume that we have kept our scores in order. So let's say that we had, and these are probably too small for you to read, but Mike had 1105, Rob had 750, Paul had 720, and Anna had 660. And let's say that I come over here and I want to add Jill, who has 740. So what should happen okay, here you can see, okay, first off, what was my n what constructor did I call? I called scoreboard. I ran scoreboard, new scoreboard, and if I had this current situation, what did I pass in as that n value? Yeah, exactly. 8 is what I passed in. And then how many times have I called the add method before this? I've called it 4 times, exactly. So I'm about to call it for my 5th time, and I am receiving Jill with a score of 740. So can anyone tell me in words, what should happen with my array of game entries? Yeah. Yeah, exactly. So I need to shift. So 740, it should go in between the score of 750 and the score of 720. And so so that's what we want to put in. Let's look at our nice picture that I copied over from the book. So first off, everybody's got a shift that, everything. This was 1105, this was 750, this was 720, this was 660. So first off, we've got to open up that slot for my new score, and then we got to throw it in there, which I just will do because I can. All right, Jill, come to where you belong. Right there. Okay, so that's what we got to do. So we understand it visually, we understand it in words. Now, how do we do that in code? Okay, so where should we start? Let's see, so first off, let's make one check. Is this score, should we even put this new score? Okay, so we did this. We don't want to do this anymore. Should we even put this score in? So what do I need to check to see if I should put the score in? Like what's one, yeah. Yeah, so how can we compare it to the lowest score? So, how do I get the lowest score? Well, okay. How do I access? So remember that we are assuming that we've kept everything in order. So we're going to implement this so that we're always in order. Yeah. What was that? So, okay, so we got some ideas. So the length minus 1, so the length is n, maybe? Is that what you're... Yeah. So we've got with this n, which actually we don't even have... Okay, yeah, we don't have access to n, but we could do something like... It's like... There's some way to get the length of an array. I don't have it off... What was that? Sure. We have one idea, which is to get the length of the array minus 1. So this will give me the last slot, like, I guess, board at board.length minus 1. That might not be correct Java syntax, but we won't worry about that. So this gives me the last slot, but what was that? Sure, yeah. So, okay. So this will call get score on the very last thing in my array. We have an example here. Like what would that do in this case? What slot would I be trying to call get score on? Yeah. Yeah. Yeah, but okay, how do we get the last spot? It's not, so if I do length minus 1, so here my length was 8, right? Length minus 1 is 7, but what's in 7? Nothing's in 7. So what's my lowest score? Well, it's 660. So how do I get 660? Yeah. Yeah. So, okay, so this one that I just wrote would only work if the board is full, right? But it might not be full. So then another idea is loop through until the next one is null. That would work, but we have an easy way to do it, yeah.
I would just say
Yeah. Exactly. So we have this num entries, and we knew, like, we already used it because it's the thing after me. Like, it's the thing after, let's look at my picture again because I love pictures. Num entries in this case is 4, right? So 4 would put me right here. I just want the one right before num entries. So, great. So board at num entries minus 1 dot get score is going to give me the current lowest score. So we got there. So we're definitely going to want to use that. So I'll just delete these lines so that we can have a little. So lowest score is that. So great. So I definitely want to put this in if I'm bigger than the lowest score, right? So if E dot get score, please. Is that not? Oh, okay. It's just prematurely trying to tell me that this isn't going to work. But certainly, if E dot get score is greater than my current lowest score, I definitely want to add it. So we just got that. Then I should add. So yeah, okay. Let's keep going with this idea. So we should add. So I like to take care of the easy thing first. So we're going to add it. So one easy thing that we're going to need to do, can anyone tell me some really easy thing we're going to have to do when we add? We actually already did it. I'll just copy it. We need to increment num entries. Great. Check. Did the easy thing. So now we got the hard thing. So we increment num entries. So now what's the hard thing? The hard thing is find the right place to put it and shift everyone over, right? What's our time? 3:52. Okay, we'll keep making progress on this till the end of class today. So, okay, any ideas here? How am I gonna accomplish this? Yeah.
This isn't the same idea, but don't you also want to add it if your num entries are less than the total entries regular?
Yeah, so that's a really good point, and so personally, when I'm developing software or writing code, sometimes I like to get something working even if it's not like perfectly doing everything right. So you're exactly right that really, in the end, we should have two cases when we add it. It's not just when it's a better score, Also, like if we go back to our picture, so let's say now we're in this second case, and we come in and we have a score of, I come in with my score, and it's only 100, and I want to add it. Well, it's not bigger than any of the scores here, but because luckily for me, our scoreboard holds 8 scores, I still get a high score, right? And so in this case, I should just put it there. But you're exactly right. So how would we write that? I think we didn't explicitly cover this, but in Java, the operator for OR is this double bar. I think it's the same in a lot of languages, so hopefully that's familiar to you. I'll just say, reminder, this is the OR operator, and does anybody remember or know or have any guesses about the AND operator? Yeah, double ampersand is the AND operator. So, yep, so if so we have if it's a better score, or if I just haven't filled up my board yet. And this is where we probably use the length. Yes, okay. This is the Java syntax that I did not remember. If I will put it in here. So board.length is how we get the length of the board. Do you want to tell me, so what should I do? How can I compare to board.length? Yeah, exactly. As long as I have more spots than I should add. Okay, so we're into our adding. Yeah, we'll keep going.
So we're trying to check, like, if we're, the first piece, like, EFX score is larger than board length, but we're trying to check to see if this decays are harder this cat, right? Because EFX score is less than the last sorted score, we just added to the number, right?
Yeah.
The second part, we're saying, do we have the room in our object, right?
You're saying,
Room in our array of entries.
you're saying for this one?
Yeah.
Yeah. So you're right that we could handle these differently.
But, like, is that what it's supposed to be doing? That's not using more things.
So my claim is that my claim is that we can actually handle both of these with the same code. And it'll work out. Yeah. But you're right that a different way to do this would have been to check. We could make one check for this, or I think this is what you're saying. We could make one check here, and then we could do this whole shifting thing, and it's a little bit complicated. Or, and if that check fails, then we can also check this, and we can do something easy, which is just put it at the end.
Well, I'm more saying, like, let's say we already have 8 remotes in our school board, and we want to add another one, we can. So we're going to do a check for that. Because that's why the thing we're doing before that thing is larger than that.
Well, but what if I do have 8, like, okay, this is totally filled, coming back to our picture. So let's say that we added Lucy with her SAD score of 100. We added 2 more, so it's totally full. But then I come in and I want to add a score. Someone comes in with a score of 800.
Oh, so you overwrite stuff?
Then I don't overwrite it. Well, I do overwrite it. I shift everyone down and I kick out the bottom.
Right.
Yeah.
Okay.
Yeah, I should shift everyone down and kick out the bottom. Yeah. Oh, that's a really good question. I think I'm kind of hoping maybe that when we maybe accessing num entries -1 would, yeah, so maybe Java handles that well. That's actually a really good catch that I did not think about. And so, yeah, I'm not sure. It looks like we only have 2 more minutes, but I hope this was helpful in understanding how we go about developing programs like this and how we're using that array data structure. So the completed scoreboard is here on the website, and there's also a scoreboard demo on there as well. And so next class, we will take a look at the full implementation of the scoreboard and demo it a little bit, and then we'll move on to linked lists. So you can go ahead and take a look at this on your own time as well.
When you implement the class movie in there, do we just leave it as just class movie and don't have anything in front of it? Because whenever I try to do like public or
Yeah.
okay.
So you can, I think I said you can do it in the same file or not the same file.
Okay.
If you do it in the same file, then yeah, you have to leave the public off.
Okay.
That's basically just like the Java rule. You can only have one public class, but it's fine to have a non-public class. So,
Okay.
yeah.
Thank you.
You have your question?
Yeah.
Yeah. Is it quick or should we?
It should be quick.
Okay, cool.
I think it's quick.
Yeah.
So, I have 2 different
Oh
ways.
wait, let me actually successful.